The half-life of radioactive carbon-14 is approximately 5,730 years. What percentage of carbon-14 remains after 15,000 years? So, this is an exponential decay question, but growth and decay, they are very related. So, you just need to know, this thing, we have A amount equals A0 times B to something here. I could put a T as in time, but for half-life it's not necessarily we need a time, we need some kind of power, and it's kind of related to, similar to compound interest, not related, but it's the number of half-life. This n is kind of like the number of half-lives here, number of half-lives in the given time. So some power there. A0, remember, is initial amount, which we don't really have, but I'll discuss that when we get to it. A is the amount at any given time. Amount of substance, in this case it's the amount of carbon-14, but it could be the amount of all sorts of things. B is, it's thought of as a growth or decay factor, but it's basically the base. We are talking about half-life, so half-life means the base is a half, because after each half-life the amount of substance halves. So imagine it was like one half-life, you would get this initial amount, you times it by a half to the power 1. If it was two half-lives, you would half twice, and so on. So this B is kind of like the base. Growth factor, in this case decay factor, really in this specific case it is a half. So basically we need to ask ourselves the question, how many half-lives in how many years? We're 15,000 years. If the half-life, is 5730. Both of these should say years really. So like that. So all you're really saying is how many times does 5730 go into 15,000? That's how many half-lives there would be. So you know it's going to be between 2 and 3. So 2 point something. We don't really need to know exactly. Well, we do need to know exactly what it is. We certainly don't need to know it as a decimal. So, but it's basically 15,000 over 5730. That will tell you how many half-lives happen in this time, given that we know that the half-life is this and this is the time period. That's how many of these things will happen. So now we can go on to answer the question. Now we want a percentage. We want the percentage that remains after 15,000 years. So I reckon you don't have to do this, but I'm going to start with an initial amount of 100, because 100 is 100% to start with, and then if I do it, then the answer that comes out will just be the answer, and I don't have to do anything else with it. So I'm going to say A0, so let A0 equal 100, as in it's 100% of the substance. So A, if it's after 15,000 years, equals A0, so 100 times the base, so 1/2, to the power of the number of half-lives, which is this. So 15,000 over 5730. That's our power. We'll work that out, plug it into your calculator, and it comes up as 16.29158. So as I was saying, that because we've stuck A0 in as 100, that the answer just is 16. I've got this too a little, therefore 16.3% of carbon-14 remains. Okay, and that's it. We haven't been asked for a model or anything. Obviously, be aware that this question could branch out into lots of different places, but in this case it's just really getting you to understand that you're not putting a power just as 15,000 years, because it's not quite as simple as that, because we're interested in how many decays would happen in this time.